Hey y'all, let's go ahead and get started with product of powers. So on this one here, when I have something that has the same base but a different exponent, what we are going to do is we are going to keep the base and we are going to add the exponents, okay? So this one here, I have the same base and the base is x. So I have x and x. So we are going to keep the base and we are going to add the exponents, 3 plus 4. So that is equivalent to x to the 7th power. Okay. All right, next one. The exponent goes with y here as well. The exponent goes with y. So I have a 2 and a 4 that are the coefficients. Okay, so when I write this, I'm going to have 2 times 4 times y to the 3rd times y to the 1st power. So if they don't put an exponent, remember that the exponent is 1. So 2 times 4 is equivalent to 8. 3 plus 1 with these exponents gives me y to the 4th power. All right, the next one here, -4 times 5 times x to the 3rd times x squared times y squared and times y to the 3rd. -4 times 5 is -20. X to the 3rd times x squared is x to the 5th. And y squared times y to the 3rd is y to the 5th. Okay? All right, so that is a product of powers. Now let's go on to a power of a power. So on this one here, when I have an exponent on the inside or a power on the inside and a power on the outside, we are going to multiply those exponents. So I have x to the 3rd to the power of 4. So that's x, and then I multiply 3 times 4, which gives me x to the 12th. Now here I've got y to the power of -2 raised to another power of -4. So that's y. Negative times negative equals a positive. 2 times 4 equals 8. And on this last one, I have 4. And then x to the 3rd is 3 times x. All right, let's go on to the next one. So power of a product. On power of a product, this is going to say that every base, so I have the base of A and the base of B inside the parentheses, is each going to get its own exponent, m. So when I break this apart, I have A to the m power is being multiplied to B to the m power. All right, so here I have x to the 1st power. So I have x to the 1st power, also to the 3rd power, times y to the 2nd power to the 3rd power. This is the power of a product, but it's also using the power of a power rule. Because there's exponents inside the grouping and there's exponents outside the grouping, we multiplied them. So when I look back here, there was exponents inside the grouping and there was an exponent outside the grouping, so we multiply those. So this is x to the 3rd times y to the 6th. Okay, this next one, -2 has an exponent of 1. So I have -2 to the power of 2. And then I have x to the power of 8. -2 squared is positive 4. X to the 8th. All right, in the next group, 4 has an exponent of 1. X has an exponent of 1. Y has an exponent of 2. And Z has the power of 3 or exponent of 3. And they're all raised to the power of 2. So I have 4. 1 times 2 is 2. Then we have x, and 1 times 2 is 2. Y has 2 times 2, which makes 4. And z has 3 times 2, which makes 6. Now, x squared, y squared, or y to the 4th and z to the 6th, they're variables. I don't know their value, but 4 squared I do know is 16. So I have 16 x squared, y to the 4th, and z to the 6th. All right, so on this front page, the ones that I'm assigning are 1, 3, 5, 7, and 9. There are a few opportunities for extra credit here, so let me tell you which ones those are. These 3 here, each one counts as an extra credit point. These ones here, each one counts as an extra credit point. And these ones here, each one counts as an extra credit point. Now, in order to be considered for extra credit, they have to be turned in on time. This cannot be late, okay? All right, that's the front of the worksheet. Let's go to the back side of it. Okay, quotient of powers. Instead of adding the exponents, this time we are going to be subtracting the exponents. So they have the same base. And now, since they're dividing, we're going to subtract. And you always want to subtract the biggest number from the smallest number. So if I looked at this here, there's more x's on top. So let me try to show you this in an expanded form. So if I have 10 x's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And on the bottom, there's 4. Now, if I was to simplify this, and I canceled these out, I'd be left with x to the 6th in the numerator. In the denominator, there's nothing. We can write that with a 1. However, we know that a 1 in the denominator is not necessary. So we can just say x to the 6th power. Now, what if it was the other way around? What if it was x to the 4th over x to the 10th? So we had 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now here, these would cancel, these would reduce to 1, reduce to 1. And then what we'd be left with is x to the 6th in the denominator. But here, I cannot leave a numerator empty. There has to be something there. So we put a 1 there for the space holder. So just like we put a 1 in the denominator, we would put a 1 in the numerator. A 1 in the numerator, though, we need to have. A 1 in the denominator, we do not need to have. Okay? So we're always going to look to take the biggest number minus the smallest number, but pay attention to where it's left over. All right, here, 12 divided by 3 is 4. It's 4 over 1, really. Okay? Then t7 to t squared, we subtract them. 7 minus 2 is 5. Because there was more in the numerator, we leave t to the 5th on top. We don't need that denominator of 1, so we can just write 4t to the 5th power. Okay, the next one. 5 over 15 reduces to 1 over 3. Then I have z to the 6th divided by z to the 4th. 6 minus 4 is 2. There was more left on top. So we could write that as z squared divided by 3. Okay. All right, let's go on to a power of a quotient. This is similar to, let me go back up here. this is similar to a power of a product. Each piece inside the group gets its own variable of m. So here, each piece inside of the group will get its own variable m. So I will have a to the m power, b to the m power. So on this one here, x has a power of 1 currently, 2 has a power of 1 currently, so that'll be x to the third power, 2 to the third power, x to the third power remains x to the third, 2 to the third power is equivalent to 8. All right, on the next one, y squared to the second power, x to the first to the second power. So in the numerator, I have y to the fourth, and the denominator, I have x squared. Okay, and this next one, 3 over 4 right now cannot be reduced. Okay, so if we could reduce that first, we would. But then I'm going to have 3 to the first power, x to the first power, 4 to the first power. 1 times 4, so that's 3 to the fourth power. Then x to the 1 times 4 will give me x to the fourth power. And the denominator, 1 times 4, that's 4 to the fourth power. And then I have 5 times 4 is y to the 20th power. So remember that we still need to simplify the ones that are just numbers. Okay, so when we're looking at these, the first one we have is 3 to the fourth, which is 81 times x to the fourth. And then in the denominator, we have 4 to the fourth power, which is 256, and then y to the 20th power. Okay? All right, negative exponents. We cannot have a negative exponent. So whenever we have a negative exponent, and right now this one's in the numerator, we are going to switch the location. So if it's in the numerator, it will move to the denominator. If it's in the denominator, it will move to the numerator. But only the piece with the negative exponent will move. Okay? So in this case, a to the negative m is in the numerator. So now it will move to the denominator, and it will have a positive exponent. Now remember, the numerator cannot be empty, so if there's nothing left there, we must put a 1. Okay, so here I have a to the negative 4. It does have a 1 in the denominator that we don't need to write. When I rewrite this, I have a to the fourth, but I need to fill the numerator with something if nothing's there, and that would be a 1. Now here, 5 has an exponent of 1. 1 is not negative. So when I write out my fraction, 5 to the first can stay in the numerator, and x to the negative second power moves to the denominator. Okay, let's look at the third one here. We have a fraction. 3 has a positive 1, so that stays in the numerator. 5 has a positive 1, so that stays in the denominator. X squared stays in the denominator. And y to the negative 3 will move to the numerator. Okay, and the last one. On the last one, we have the 0 exponent, which we practiced in class. Anything to the 0 power always equals 1. Well, here 0 is touching the parentheses, so that means everything in the parentheses is 1. Here we have 0 touching 197, x to the third, y to the fifth. But since it's all in the parentheses, then this is equivalent to 1. All right, the last example. 0 is touching the x, but it is not touching 15. 15 is currently to the power of 1. So that means I have 15 times x to the 0 is 1. So this gives me 15. Okay. All right, your homework on the back side is 1, 3, 5, 7, and 9.